Here we go. We have a question: construct tree from in order and pre-order. So you have given two arrays representing the in order and pre-order traversal. I hope you are already aware of the in order and pre-order traversal of a tree. So we have given these orders of a binary tree and we need to construct the tree itself and return the root node. So we have given this tree and this tree. So the resultant is this. Its in order is left node then right, and pre-order is node left and right. So first we have node, then left we don't have any node, then for the right side we have a node, and uh, we have a node, then its left side is null, then we have its right side, right side, right side, then its left side is 8. So this is in order and pre-order. We have given these three examples, and I will take this example and explain you the approach. So we have given this and this. Let's try to build the approach. So the first node is this pre-node. First node is the pre-node. So we will build this node. We have built this node. We have used this node, and we need to find what are the nodes that are present on the left hand side. So the 0 node is here. It means all the nodes on the left hand side, all the nodes on the left hand side will be in the left side, and all the nodes in the right hand side means after that index will be on the right side. So there are in total 3 nodes on the left side, so we will took 3 values, and after that the remaining values will be on the right side. So first of all, if I took a value, I need to find its corresponding index in the in order traversal. I need to find its corresponding index in the in order traversal. So first let's create a node. Let's build our map. We will use map. So 3 on position 0, 1 on position 1, 4 on position 2, 0 on position 3, 2 on position 4, 5 on position 5, and you don't have to worry, all the values is unique, all the values are unique. So it is given in the constraint. Then first we create this node. We have starting of pre, ending of pre. So starting of pre and ending of pre. Then we also have starting of in, ending of in, ending of in. So we will use starting p. We will use starting p. I have used the starting p. Then I will find the index. I will find the index. We know the value. Value is this. We will find the index. We know the index. Index is 3. So we have named it id. How many nodes are there? How many nodes are there? So what we'll do? The left side nodes are, in total we have id id minus starting of in number of nodes on the left side. So we have 3 nodes. So we have 3 nodes in the pre-order also. So now the question remains this: in order is 3, 1 and 4, and pre-order is pre-order, yes, 1, 3 and 4. Then on the right hand side we have this many nodes. Its in order is 2 and 5, and its pre-order is 2 and 5. So we have broken down our problem. So how will the recursive code look like? We have a solve function inside of which we have SI parameter, EI parameter, and in. So this is for in. Then we also have what we have, starting of pre, ending of pre, and pre. We have these many arguments. Then we will build node is equal to pre of starting. Then solve function, first of all we need to find the ID. Using the map we will get the ID, get of node. Then on the left side we have ID minus starting of in. Yes, starting of in. Then node dot left will be we have a solve function. So starting I will remain same. This is for the left side, this is for the left side. So starting I will remain same, and starting end for the in order traversal, starting end will be ID minus 1. This is in, this is starting of pre. This is all about in node. Then what about this? So we have three nodes. We know the length. So it will be starting plus number of nodes on the left side, and ending remains same, EP. Then pre, this is for the left side. What about the right side? Node dot right will be solve of. So what about this side? For the in order it is simple, ID plus 1 to end, ID plus 1 to end means EI. This is in order. Then that many nodes. So we know there are 3 nodes. So we are on to this index. We know left is 3. What is left? Left is the difference between ID minus SI. The difference between ID minus SI. So this many on the left side. So left value is 3. So left value is this. So I can say left plus 1 to EP. SP plus left plus 1. I think yes, I have made a mistake here, to EP till pre. And here the value is SP we have used, and EP is not our boundary. SP plus 1, this is the left side. So SP plus 1 till 3, 0 1 2 3 till 3 means SP plus left. We only have 3 values on the left side. So that's how it will work. So the remaining code, we need to just believe in the leap of faith, and it will do the work. It will create the node. So let me create it. So first we have 0. Then for this node I will use my pre. So I will use my pre, and all the values on the left side and all the values on the right side. So I will again use my pre 2. So 2 is there, 2 is there. Then 2 is there, no value in the left side, all the values on the right side. So this will be my answer. 0 1 2 3 4 5. I think this is the expected answer. 0 1 2 3 4 5. Yes. Now let's code this. First thing, map, store the in values, in order values with the corresponding index, then pass starting of in, ending of in order, starting of pre, ending of pre, then pre, and also map. Then use your, so this is our base condition. If starting exceeds ending for any of the array, either in or pre, so just return null. Else create your pre node and get the value. Then left side nodes is id minus si. So this is my answer. This will be that much nodes on the left side. So this is same as this. So si id minus 1. This is for the in, and this is for the pre. This is for the pre. So si plus 1 to sp plus 1. Sp we have just used here. So starting from next node till the leftmost node, till the number of nodes on the left side. Then for the right side, in order it is pretty simple. So we know the in order, all the values after that will be on the right side. So id plus 1 to ending, and that side. So sp plus left, that many nodes we have used in the left side, on the left side. So to the next value, starting from the next value till the ending nodes will be on the right side. That's all. Just return the node. Now let's submit this. Now let's talk about time and space complexity. So here we are onto an index only once, and we are not visiting that index after that. So time complexity is order of n, space complexity is also order of n. So time complexity is n square. I don't think this is the expected. Yes, time complexity is order of n using pre-ordered traversal and hash map. Time complexity is order of n. So we have made the expected time and space complexity. Thank you all for watching.